Good afternoon, everyone, and welcome to our Price Formation Enhancements Phase 2 Working Group Series of the Fast Start Pricing. My name is Brenda Marquez. On behalf of the Stakeholder Affairs at the California ISO, we welcome you to this meeting. Today's call, we will be covering the Fast Start Pricing topic, but before we get started, the reminders are for this call is being recorded for informational and convenience purposes only. Any related transcriptions should not be reprinted without the ISO's permission. At this meeting, this is structured to stimulate dialogue and engage different perspectives, so we encourage verbal comments as well as chat questions if you do experience any technical issues. During the time of your comments, we encourage comments to be provided in a professional, respectful manner, as well if you want to provide any brief comments, make sure you're not repeating anything that was previously said, so that would help us with our time management of this working group meeting. This slide shows how those who are on the WebEx queue to how to raise a hand. Please use the open participant chat windows on the bottom right of your screen. You'll be able to add yourself to the verbal queue if you'd like to ask a question to our panelist group. As well, be sure to state your full name and affiliation before stating your comment. Also, we also have the comments where you can submit comments about panelists, so we'll be monitoring those as well. And we'll also be verbally announcing them as well if you're not able to communicate your questions through the verbal queue. So as well, we also have Ryan, who is our event producer, who will be here assisting us in this call. And then at this last slide I'll be presenting is just the CAISO policy initiatives stakeholder process that we have. As well, I've added a graphic, just the upcoming meetings we have planned for this month. We do have another slide that James will cover on the previous slide, the previous meetings that we covered in November for the price formation enhancements, as well the upcoming meetings moving on towards this month and next month as well. So at this point, we are still in the working group phase, pre-proposal development, and also we're just moving along with our topics as well. So at this time, Ryan, you could go ahead and move the slides. I'd like to introduce James, who is our policy lead for this initiative, and he will be also introducing Danny Johnson, who's also here with us today, and Mike Hollider, too, who's also here with us from Atlantic Economics. Thank you.
Brenda, can you confirm you hear me?
Yes.
All right, wonderful, and good afternoon, everybody. So today is the fourth working group meeting in the series of price formation enhancements, phase 2. Today's topic is fast start pricing. And here are the objectives of today's meeting. We have really two distinct topics within the fast start pricing umbrella that we want to talk about today. The first is how to amortize fixed commitment costs across different time periods. So in the previous workshop, the working group discussed how to, or different methods for amortizing commitment costs over a resources output. And today we're going to be talking about how long should the fast start pricing logic apply in the real-time and day-ahead markets. So we'll get into that. We'll talk about the implications of implementing fast start pricing in the day-ahead market. And for both of those topics, we will look at different ISO RTO approaches to these implementation decisions and also guidance from FERC's 2016 NOPR on these on how markets were suggested to implement these things. So by the end of the meeting, hopefully we have a better sense about how these things will come about. Next slide, please. So this is the timeline of the fast start pricing working group discussions. Our previous discussion held on November 14th talked about exploring initial design concepts, reviewing some of the methods to amortizing commitment costs into market prices. Today, we'll be continuing the exploration of these initial design concepts and talking about how long to amortize the cost and whether to apply fast start pricing in the day-ahead market. So looking forward, we have quite a few future working group sessions planned for fast start pricing. We did confirm that on December 19th and January 16th sessions on fast start pricing, we will have guest speakers from other markets come, and we're very excited and grateful for their time for that. So on the December 19th session, we have Shu Zhu from MISO and Carrie Milton from Potomac Economics, who is the MISO market monitor, who have volunteered to come and provide their perspectives on fast start pricing and also to provide more information on how MISO has implemented fast start pricing and any challenges and that they've overcome there. So staff and stakeholders, everybody in the working group will have the opportunity to ask questions to the MISO staff and MISO market monitor. So it'll be a good session. And then on January 16th, we've also confirmed similar participation from PJM staff and PJM market monitoring staff to provide, again, discussion about the mechanics in PJM, how the fast start pricing is implemented, and then the market monitor will come and share their thoughts and perspectives on fast start pricing. So again, we've confirmed those participants. We're really happy and grateful that they've donated their time to help our working group. If you have questions that you would like us to pass on to either MISO, PJM staff, or the respective market monitors, feel free to do so. I have gotten at least one set of questions that I have passed on, and so if you, it will help these folks prepare. If you know that you have specific questions, it would be helpful to send them to them in advance, and I can, either Brenda and I can help facilitate that. So please do share those if you know you'll have questions. And then you'll see a number of upcoming sessions dealing with interactions of fast start pricing with various market features in the CAISO. And so CAISO staff is working on preparing for those types of discussions and making sure that we can all learn together what these interactions for these various market aspects might be, so that we can develop a fast start pricing approach that works with is consistent with the CAISO's existing market design and fleet of resources in the Western EIM and EDAM. I'll take a quick pause on the schedule if anybody has any questions or clarifications. Okay, I'm not seeing any hands, so let's move on to the next slide. Here's our workshop agenda for today. Thanks, Brenda, for welcoming us and introducing the topic today. We're going to take the first 30 minutes or so of today's session to review the previous working group and the format that we used for the previous BA level market power mitigation call was pretty successful, in which we sort of review and discuss some of the key questions that were asked in the previous session. That tends to get us caught up a little bit on the discussion and give us a chance to revisit some of the key questions. So we'll do that. And then Mike and I will tag team the second section, which is to discuss the amortization periods that are appropriate for fast start pricing, and then also discuss implications of fast start pricing in the day-ahead market. And then we'll have open discussion and Q&A as needed at the end. Next slide, please. All right, so we'll jump into first a review of the previous working group meeting. Let's go to the next slide. So here's a very high level summary of the meeting that we held last time. I believe it was on November 14th. The presentation and the recording of the presentation should be available on the CAISO's website and the Price Formation Enhancements Initiative page. But generally speaking, we talked about the three different methods that we've discussed so far for incorporating commitment costs into LMPs for fast start resources. And these three methods were used in the CAISO's April analysis on the impact of fast start pricing in the Western EIM. That was the simple constant adder approach, the adjusted constant adder approach, and the minimum average cost approach. So we discussed how these methods are calculated, their advantages, disadvantages, stakeholder opinions, and essentially focusing on how each approach is incorporating startup and minimum load costs into market prices. Next slide, please. So we're going to start with some major questions. I think there might be 8 in total. First, two related questions. There was discussion about whether fast start pricing should apply to all block-loaded or inflexible resources and not just those that are fast starting, since the pricing issues are similar. And then similarly, must fast start pricing or must fast start resources be block-loaded, meaning they're only on and off and they have no dispatchable range. So traditionally, fast start pricing targets resources that have fast start capability and short runtime because those are the resources that rely more on uplift to recover their costs because they're not operating for very long periods and their commitment costs may be significant relative to the energy revenues they're earning in the market. And so for that reason, fast start pricing, yes, it's true that any block loaded or inflexible resource will generate similar pricing issues where they have forbidden operating regions where they cannot set the marginal price. Fast start pricing traditionally is thought of to apply to fast start resources because of these compensation challenges. And resources do not need to be block loaded to qualify as fast start. In the original FERC NOFR 2016, FERC suggested that both block loaded and dispatchable resources should qualify for fast start. And then of course, not all resources with inflexible operating ranges meet the criteria for fast start treatment. So you may have longer starting resources that have inflexible operating ranges that won't apply to fast start pricing. Second, does fast start pricing apply to self-schedules? The answer is no. This was discussed in detail during the analysis phase of phase 1 of fast start pricing, that really any type of non-economic commitment would be excluded from fast start pricing. So for example, from the CAISO market, that could include Western EIM-based schedules, minimum online constraints, reliability must-run commitments, exceptional dispatches, et cetera. With the general principle being that any commitment decision that's made from non-economic factors would make the unit ineligible for fast start pricing because the commitment costs in those cases are not part of the economic optimization. Or in other words, the commitment costs in those cases aren't relevant in the market's decision to commit those units. They're being committed for other non-economic purposes or reliability purposes. So traditionally, fast start pricing would not apply under those times where the unit's being committed outside of economic context. Next slide, please. Question number 3, should fast start pricing apply to MSG transitions? So of course, that question itself is part of what we're here discussing is to develop the policy moving forward for fast start pricing. So there is no yes or no answer at this point to that. MSG transitions were included in CAISO's fast start pricing analysis, but whether they're included in any final policy is an open question that requires discussion. The CAISO's price formation team does think that MSG transitions have characteristics that make fast start pricing relevant. For example, transitions have commitment costs between transitions. They have transition times, which mimic essentially startup times. And so MSG transitions also have, or they don't look much different than a startup of any normal unit. And so, CAISO's staff perspective is that MSG transitions are relevant for fast start pricing, but we're open to discussion on that topic. The fourth question, would battery storage resources qualify as fast start? In the CAISO, the answer would be no, because storage resources in the CAISO markets model are always committed. There is not a traditional unit commitment process for storage resources like there are for conventional generators. Storage resources also don't have commitment costs the same way conventional generators do. And so since fast start pricing is about incorporating those commitment costs into LMPs, there really aren't any relevant costs for storage to incorporate into the LMP. So I guess to summarize, they are fast resources and flexible resources, but they have characteristics that make them irrelevant for fast start pricing. Next slide, please. Question 5, what is the relationship between eligibility thresholds for fast start pricing and expected LMP impacts? So this was discussed at length in the previous session. Generally speaking, the more generous threshold that you have, or the wider the bigger ability for resources to qualify as fast start would lead to higher LMP impacts, simply because you have more resources in the bid stack that are receiving fast start pricing treatment and are having modified offer curves that can set the price at a different level. So generally speaking, the more resources that you have that fast start pricing logic applies to, the larger the LMP impact would be. Question 6, would we be potentially double counting costs if generators are internalizing commitment costs in their incremental energy bids and then getting the fast start pricing adder? So generally speaking, you know, the market design should incentivize generators to bid their actual cost, have incentives to bid their actual costs when they're absent any market power. And so we don't think that there would be any reason outside of market power to think that resources are needing to incorporate themselves some commitment costs within their variable energy offers. And it's important that whatever design that we choose for fast start pricing, that we preserve those incentives that for generators to bid their actual costs in the absence of market power. And we talked about in the previous session that there may be, those assumptions may not hold depending on the type of amortization method we use. And so that's a very important criteria that we need to think about moving forward. Also, that generally bid cost recovery payments in the CAISO's market should reduce the need for generators to inflate their energy market bids to cover their fixed costs. And in practice, I know there were discussions in practice that you know, that may not be a one-to-one relationship, but in general, bid cost recovery payments are there to make sure that resources can recover their fixed costs, and so therefore don't need to incorporate those into their variable energy bids. Okay, and then last slide. There were questions about how fast start pricing would interact with a number of CAISO market elements, and here are listed a few that got brought up. All of these we will explore in future sessions, so we won't opine on them today. But just to you know, let folks know that we're hearing these questions and we're preparing to discuss them in future sessions. And then finally, there was discussion in the previous working group about how fast start pricing affects bid mitigation. So in the case where a fast start resource that has fast start pricing logic applied is mitigated for market power, how exactly does the bid mitigation work? We think this is a good question to discuss with the other market monitors that come on December 19th and January 16th, so we can learn from others' experience about how that's working. To the CAISO's price formation team, it seems reasonable to run the normal MPM process and apply the fast start pricing adder to mitigated bids when they're applicable. So if a resource is mitigated in the MPM pass, that the modified offer curve construction would use the mitigated bid in the market run to construct the fast start pricing adder when it's appropriate. So if the resource is using a mitigated curve, we would use that to generate the adder. If they were not being mitigated, we would use their submitted bid. And then again, to remind folks that one of the key principles here is that we need to implement fast start pricing in a manner that continues to give generators the incentive to submit bids that reflect their actual costs, and that will facilitate market monitoring and the prevention of the exercise of market power. Because when you have market rules that encourage generators to bid things other than their actual cost. It makes it very difficult to monitor when submitted bids are, internalizing actual costs or potentially exercising market power. So those are some of the key questions that got brought up in the previous session. I hope that review is helpful. I'll pause to see if there's any questions about the questions themselves or the answers, or if there are other questions that got brought up that maybe we missed that you'd like to see us think about in the future. Okay. Let's move to the next section then. Oh, I'm sorry, there is one more question. Apologize for that. There was a question brought up about fast start pricing logic applying to offline units. And in some markets, this might be called offline fast start pricing. And so, of course, no decision's been made either way. There haven't been any decisions made. So far, the material that we've discussed all the way dating back to 2022 has not considered offline units as eligible for fast start pricing. But, the answer here does share that in some cases, there are markets that do incorporate offline resources in their fast start pricing. The original FERC NOPR did not require offline units to set prices, but did allow them to under some unique circumstances. That's listed in the bottom sentence there. For example, during transmission constraint violations or energy shortage or ancillary service shortage conditions. And so MISO, I understand that MISO has had some offline fast start pricing in their market over time. And I understand those things to have changed over time. And I'm pretty sure that MISO's market rules have over time reduced the amount of instances where offline resources can set price based on some issues they were seeing. And so we can definitely ask MISO staff and their market monitor to talk about their experience with offline pricing. And then Mike may be able to say more about NISO, who have implemented changes to its procedure for setting prices when there are transmission constraint violations, and NISO's plan is to eliminate offline fast start pricing sometime in the future. So it does seem that the general trend is moving away from using offline resources to set fast start prices, but we can talk a little bit with MISO staff about that if folks are interested more in that. Okay, let's go to the next slide, please. All right, so we're switching gears now to instead of discussing the previous working group session, we're now moving on to new material. So this is the first of two topic blocks that we'll talk about new material today. Let's go to the first slide, please, in this group. Okay, so let's talk about amortization and why it's crucial for fast start pricing. So at its core, amortization, the term amortization is talking about taking fixed costs that generators incur when they start up and spread them out over time in a way that makes economic sense. So when a fast start generator turns on, it faces two types of fixed costs. First is the one-time startup cost, and then what we call minimum load costs in CAISO market, which are costs that they incur just to stay running at their minimum output level. So the challenge is that these costs are lumpy. They come all at once, but we need to figure out a way to incorporate them into our per megawatt hour energy prices. So think of it as, how do we take these fixed costs that occur at one point in time and spread them over a per megawatt hour basis so that we can add them into our energy offers. So without amortization, there would be a problem. Fast start units that would run for short periods would rarely be able to recover their fixed costs through the energy market revenues alone. And we'd have to rely heavily on separate uplift payments or make-whole payments, which are less transparent. So by amortizing these fixed costs and converting them into a per megawatt hour adder to the unit's energy bid, we can better reflect the cost of serving load and directly into the market price. So this is especially important for fast start resources since they often run for short durations, specifically to meet peak demand or address unexpected system needs. So the key question that we'll explore further in these slides is exactly how we should spread these costs, both across the megawatts a unit produces and across the time it operates. And different markets have taken different approaches, which we'll examine further. Next slide, please. So let's break down the key types of commitment costs in CAISO's market. First, we have startup costs. These are one-time fixed costs that occur when a unit transitions from being completely offline to online. You can think of expenses like the fuel needed to get the unit running and any wear and tear from the startup process. A special case of startup costs appears with multi-stage generators, or we call them MSGs for short. These MSG units can have different operating configurations, and moving between them incurs what we call transition costs. So they're similar to startup costs, even though these transition costs are occurring while the unit effectively remains online. The second major category is minimum load costs, which are measured in dollars per hour. These are the costs a generator faces just to stay online at its minimum output level. A unit incurs these costs continuously for every hour it remains committed. So I want to make an important distinction here to note some terminology differences. That the term minimum load cost and no load cost are often confuse people. So I just want to be clear about their distinction. No load costs, which is not a term we use in the CAISO, are strictly the fixed cost of keeping a unit synchronized with the grid, while minimum load costs include both the fixed cost plus the variable cost of producing at the minimum output. So in CAISO's market design, we work with minimum load costs rather than separate no load costs, which is important because if you're reading materials from FERC or from other markets where they reference the term no load costs and how they're amortizing those into the price, it may not be an apples to apples comparison to CAISO's minimum load costs because the no load cost is not incorporating the variable cost of operating at the resource's minimum output. Next slide, please. So the key question we face is how to properly spread these commitment costs across time. So as shown in this slide, we need to consider two components. First is the startup cost, which is the one-time fixed expense. Second is the minimum load cost, which is multiplied by the minimum uptime, which gives us the total fixed running cost a unit must incur once it's started. So together, these form the total commitment costs we need to allocate across time. But timing matters significantly here because a fast start unit might be committed to meet a very short-term need, perhaps just 15 minutes to peak demand. And the question is, should we spread those costs across its entire minimum runtime or concentrate them in the period when the unit was actually needed? Or should we spread those costs across the entire expected output runtime of the unit? So there's a lot of different variations about how those costs might be spread that we'll talk about. The markets need to establish clear rules, not just for how these costs spread over output, which we discussed in our last meeting, but over time. These decisions directly impact price formation for fast start pricing. Next slide, please. So we'll start with some guidance from FERC and their notice of proposed rulemaking on fast start pricing back in 2016. Their core position at that time was that commitment costs should only be included in the price during a resource's minimum runtime. So for startup costs specifically, FERC proposed spreading them over both the minimum runtime and the resource's maximum operating limit, which creates a direct link between the cost and the unit's actual capability to serve the load. For no load costs, FERC took a simpler approach, suggesting to divide the maximum operating limit, or divide by the maximum operating limit, since the no load cost, and again, we're using no load cost in this context because the FERC NOPR uses the term no load cost. But we just have to divide by the maximum operating limit because no load costs or minimum load costs are already in dollars per hour units. So you don't need to add any sort of time component there, which makes sense. These costs are incurred continuously regardless of the resource's output level. So FERC's proposal essentially set a standard that many ISOs followed. The logic is pretty straightforward. If you know a unit must run for at least its minimum runtime, that provides a natural period over which to spread these costs. But some alternatives have arisen over the years, and we'll talk about that, but this is what the original FERC NOPR had proposed. Next slide, please. A little more detail from the FERC NOPR. Sorry for the big blocks of text, but I want to acknowledge that the notice of proposed rulemaking did acknowledge some tension here, that commitment costs could technically be considered marginal system costs beyond a unit's minimum runtime. But at the time, FERC recognized that trying to amortize those costs over longer periods creates practical challenges, especially in the real-time market. And the core issue was that after the minimum runtime ends, well, when the market, or when the FastStart resource is committed, you know that the length of the commitment time during the initial commitment. And so the idea being that, well, if you could amortize those costs over the resource's expected runtime instead of their minimum runtime, to the extent the expected runtime might be 2 hours, even though the minimum runtime might only be 30 minutes. And does it make sense to amortize those costs over the entire time they're running, or just the minimum runtime? And that has direct implications on the magnitude of the FastStart pricing adder and how those costs might be recovered. But the key uncertainty here was that when the market commits a resource, you know at that point of time how long the market's expecting that unit to actually run. But then in subsequent unit commitment runs, the market may actually decommit the resource if it's no longer economic. So you might think when the unit's committed, it's going to run for 2 hours, but then a couple intervals later, the market might decommit the unit after an hour. And then while the unit is running, you may have tried to amortize its costs over a 2 hour period. It only runs for 1 hour, and therefore you only recovered half the cost. So FERC concluded that using the minimum runtime was a reasonable compromise. It's a guaranteed operating period, and it provides a stable basis for cost allocation, but they remained open to alternative approaches if markets could demonstrate better solutions for amortizing these costs. So these are concepts that were discussed in the FERC NOPR, and markets have, in some cases, taken a different approach, which we'll talk about on the next slide. Next slide, please. So this table represents a comparison of other ISO approaches. We do see some common patterns emerging. So most markets follow FERC's guidance on startup costs and amortize them across the resource's maximum output and minimum runtime. So that's pretty simple. For no load costs, a few of the ISOs take a different approach. ISO, New England, MISO, PJM spread these costs over the max output for the entire duration a unit runs. But the key distinction here is that in the FERC NOPR, they were thinking about spreading these costs over the expected runtime when the unit is committed. But for no load costs or minimum load costs, these are costs that are incurred continuously. And so outside of startup costs, it's reasonable that you can continue to amortize the no load costs as long as the resource remains operating, and you don't have to anticipate how long the resource is going to be running. So these markets basically say, as long as the resource is running, we will continue to amortize their no load costs into the price. SPP differs slightly. They only amortize the no load costs over the minimum runtime as well. New York takes a unique approach that, because they have the minimum average cost algorithm that's unique among the ISOs, they have a slightly different approach. Mike will talk more about this later, but New York ISO looks at the first 15 minutes after the startup in real-time market, which reflects their experience that most fast start commitments are made to address immediate system needs. And so if Mike wants to elaborate that, he can feel free. But essentially, the summary here is that there are some common principles. You see some extension of the FERC principles here, but markets have adapted their approaches based on their specific system characteristics and needs. Mike, is there anything you want to add here on the New York ISO approach before I move on?
I think that'll be fine. We'll just get into more detail in a couple of slides here.
Okay, great. Next slide, please. Okay, so I'm going to transition the PowerPoint to Mike here. Mike was kind enough to put together some examples here to help us think about some of these assumptions, and this will really demonstrate what the difference is in terms of the fast start pricing adders, depending on the time assumptions that you're using. So Mike, thanks, and go ahead and take it away.
Sure. So yeah, we're going to go through a couple of examples here. They're all based upon this common set of assumptions. So we're going to be considering a fast start generator. Well, it says P max, but it should say P min is 50 megawatts. Sorry about that. It's got a P min of 50 megawatts. It's going to have a P max of 100 megawatts, as we'll get to in a minute. Its minimum load cost is $2,000 per hour, which comes out to $40 per megawatt hour. And once we get the Pmax corrected to be 100 megawatts, and we excuse me, the Pmin corrected. The Pmin is 50 megawatts. Pmin is 50 megawatts, so the min load cost is $2,000 per hour. The startup cost is $500. So, and we're also going to assume that it's got a minimum uptime of an hour. You know, there's, as we've discussed in one of the previous presentations, there's a question as to what would be maximum minimum uptime for a unit that would be eligible for pricing. You can set it to an hour, you can set it to less. I'm setting it to an hour for this example, mostly just to make the math simpler. It's easier to multiply things by 1 than multiplying everything by 1/2 to accommodate a 1/2 hour minimum uptime. So let's just assume that, you know, it's got a 1 hour min uptime and that's a fast start pricing eligible generator. So that means that its commitment cost is going to be its $500 startup cost, and it's $2,000 per hour times 1 hour, $2,000 minimum uptime, minimum load cost. So a total of $2,500. So when we commit this unit, we have committed to incur $2,500 in cost to start it and to run it at least at its minimum of 50 megawatts for at least an hour. We're also going to assume this unit has 2 incremental output segments. It's got its cost to increase its output from 50 megawatts up to 75 is going to be $30 per megawatt hour. And then its cost for the second block, which goes from 75 up to its Pmax of 100, is going to be $70 a megawatt. So we have the first block, which averages, Pmin block averages $40 plus the startup cost. The second block is at 30, the third block is at 70. So given those assumptions, next slide, please. Thanks. So we have $2,500 in commitment costs for this generator. How should we allocate it? And one approach, as you know, James described on the previous slide, is just to basically allocate them all evenly over the 1 hour minimum uptime. Okay, and so how would that work? We've got 3 different approaches that we've discussed for calculating, you know, the modified bids that would be used in the pricing run under fast start pricing. The first 2 just essentially calculate an adder. So how would the adder be calculated? Under the cost adder approach, we would just take the commitment costs, 2,500. We would divide that by the 100 megawatt hour output, 1 hour times 100 megawatt Pmax, gives you $25 per megawatt hour. So we would basically take all the offers and increase them by $25. The adjusted constant adder approach is slightly different in that the numerator takes the commitment cost of $2,500 and it says, gee, That's my cost of starting up and operating at the 50 megawatt minimum for an hour. But I'm getting, I'm adding that to an offer that already assumes the first block, the P-min block, will be priced at $30 per megawatt hour. So which is the offer that was submitted at that first incremental block. So we shouldn't double count that. So what this approach does is it says, I'll take the $2,500 in commitment costs, subtract off the $30 offer that's going to be assumed for the P-min block times the 50 megawatt hour size of the P-min block. And so 2,500 minus $1,500 is $1,000. So $1,000 is divided by 100 megawatt hours, and that gives you a $10 per megawatt hour adder. And so that's the adder that we get using the adjusted constant adder approach. So $25 using the constant adder approach, $10 using the adjusted constant adder approach. We allocate the startup costs evenly over the 1 hour minimum uptime. Under the minimum average cost approach, it's of course a little bit different because it doesn't really calculate an adder. What we do instead is we figure out at what point are we minimizing the average cost of operating this unit. So again, during the minimum uptime of 1 hour, what's your average cost if you're going to operate at P-min for an hour? It's the $2,500 commitment cost divided by operating at 50 megawatts for 1 hour, 50 megawatt hours. So 2,500 over 50 megawatt hours is $50 per megawatt hour. So that's your average cost. You start and operate at P-min for 1 hour. What if you increase your output to 75 megawatts, which is the size of what happens if you go ahead and get dispatched into that first incremental output block? They're going to decrease your average cost? Yes, it will, because we know the average cost was $50 when you were at the 50 megawatt P-min. We know the incremental bid is $30. If I start adding output that costs $30 to an average that was at $50, adding additional output at $30 is going to bring down the average. So when I get to 75 megawatts, what's the average cost? It's the $2,500 commitment cost plus another $30 a megawatt hour, 25 megawatt hours, another $750 associated with producing, operating at 75 megawatts rather than 50 megawatts per an hour. If I divide that by 75 megawatt hours, I get to an average cost of $43.33 per megawatt hour. So increasing your output so that you operate at 75 megawatts during that hour as opposed to operating at 50 megawatts during that hour means that your average cost will decrease. It was $50 per megawatt hour at the P-min. You'd say at 75 megawatts for an hour, it goes down to $43.33. What happens if we increase output above 75 megawatts? Well, we don't need to figure it out because we can say that, gee, the incremental offer is $70. I've an average cost of $43.33 when I'm operating at 75. If I start adding output that costs $70, that's going to make the average go up. So I can't decrease the average cost anymore by decreasing my output level. And so what would happen under the minimum average cost approach is that for this 1 hour minimum uptime, we would say, gee, your offer to produce up to 75 megawatts is going to be $43.33. So 0 to 75 megawatts would have a $43.33 offer associated with it. Then increasing above 75 megawatts, you would use the actually submitted offer curve, which, as you recall, was $70 per megawatt hour. So $43.33 at less than 75 megawatts, $70 at more than 75 megawatts. Next slide, please. Now, so that was what happens.
There is one question.
Oh, sure.
Sorry,
Yeah.
there is a question in the queue. Could we take the question on that last slide, please?
Not a problem. All right. Alva, your line is unmuted. Please go ahead.
Hey, Mike, this is Alva from PG&E.
Alva.
It may be that you'll get to this at the end of the 3 examples, but I was curious on looking at the first example and the 2 approaches. A couple of cases I would want to understand. I mean, I sort of understand here that you're compensating you're showing in the market compensation to this resource that is required to have it operate at least at its minimum level, and in some of the cases to operate at a forecast level that might even be above its minimum. And in the third case, you have the possibility if it actually is in the money with respect to its bid, then the bid essentially becomes what sets the price rather than the fast start price methodology, it sounds like. But in general, is that also the case with all of these methods, that if, for example, if prices increase up to a level that would essentially have compensated the resource for its start, in any case, would there be would that then be the way the price was set, or would the adder continue to be in place irrespective of what happens to the actual sort of dispatch incremental cost as you go into future intervals? That's one question. And the other question is, what happens if the resource doesn't perform, for example, if it fails? I'm asking, actually what is being done in the other markets, not theoretically, but how are they dealing with these issues?
Okay, that's a lot. So with respect to the first question, I'm not totally sure I followed it.
It's just if the traditional LMP rises high enough that it would have compensated for the start and the minimum load, in any case, is there a
yeah. So the answer
is the component still there? That's the.
Well, the answer is going to be different for each of the. So the first thing, the answer is going to be different for the different amortization methods.
Right.
Let me go backwards and start with minimum average cost. For minimum average cost, if the LBMP was, say, greater than $43.33, the unit would presumably be dispatched to produce at least 75 megawatts. So an LBMP of 43.33 or higher should at least cover its costs during any given interval. And so if the price stays at 43.33 or higher throughout the hour, then it would at least cover its costs, including the startup. For the adjusted constant adder approach, so what's going to happen there is that allocates the cost over the full output of the unit. So you're not going to recover you're not going to be guaranteed a recovery of, and maybe a little bit trickier than actually an answer like that. I'm not sure that I can give a generalized answer for one of those.
I mean, if it goes up high enough,
Yeah.
I'm just wondering, is there, in terms of how other ISOs handle this, is it just simply put in their I mean, as you went in reverse order, it seemed like the average cost idea just basically sets a minimum threshold for the LMP, in a sense, for that period, irrespective of whatever else might happen in the market. Whereas the other two, it's not clear to me how a market would handle changes in conditions.
Well, it doesn't really set. I mean, what we're doing is we're just putting, these are offers that are being used for this unit in the pricing run. So,
okay.
So again, sticking with minimum average cost for the moment, as opposed to the actual cost structure that has a $500 startup cost plus $2,000 minimum load for 50 megawatts, plus 30 and 70 megawatt steps. So that's what's used in the actual dispatch. We're not using that in the actual pricing dispatch, because there is no place in the pricing dispatch for you're assuming the unit's dispatchable from 0 to its 100 megawatt maximum, so you can't actually specify a minimum load cost. There's no startup cost either. So what's used in lieu of that actual offer is 43.33 for the first 75 megawatts, and then $70 for the last 25 megawatts. That's what essentially takes the place of the actually submitted offer in the pricing dispatch, and then run. And if the LMP turns out to be $40, then the LMP is $40, and this unit isn't dispatched to run at all in the pricing dispatch. So it's not really a minimum price, but it does establish,
So potentially if they, like if a resource failed or whatever, it would no longer show up in the, because it's not there in the scheduling run, it's not going to show up in the pricing run either.
Yeah, I mean, when you're originally starting up a resource, of course, you're not really going to know if it's failed yet. But at some point it fails, presumably you would
Right.
stop dispatching it, and therefore it also wouldn't be in the pricing run.
Right. So it's a question of where the resource is in the scheduling run is going to really determine this. Okay, that's very helpful. I was trying to,
Okay.
I mean, it is going to have incentives, obviously, as you move through time for the continuation of that dispatch or not. But
Yeah.
what you're saying is the optimization will solve irrespective of this entire methodology. And once that solution is available, these are the things that would be used to set the price in that interval, depending on how the resource is running, actually.
Yeah. Okay.
Thanks.
Thank you. Was that the only question, by the way, or? Okay. I guess so. So let's go to the next slide. Okay, so the previous slide talked about how we're going to determine the bids that would be used in the fast start pricing for this fast start generator in the pricing run during the minimum uptime. Okay, well let's now assume we've completed the minimum uptime. Well, this is essentially just an application of the mechanism that we described before, that we went over during the last presentation, or if you want to dial way back, some of the presentations we did back in 2022, I guess. So basically, we're not going to include the $500 startup cost. It's already been recovered. It hasn't been incurred a second time. So the constant adder approach would say that the adder is not going to be. We don't have $2,500. We only have $2,000. We don't need to recover the $500 startup cost. So the constant adder would say the adder is $20. We would add $20 to the offers that were actually submitted to this unit. And the adjusted constant adder approach, again, it would take the $2,500 in the previous calculations, cross that out, plug in 2,000 instead. It would take 2,000 minus the imputed offer to operate at the P-min of 50 megawatts, which is 50 megawatts times the $30 offer that's made for the first block past P-min. So that's a $500 difference. That $500 difference would be allocated over the full 100 megawatt hours. And you get to a $5 per megawatt hour adjusted constant adder approach. So the constant adder would be $20 following the conclusion of the minimum uptime. The constant adder is 20 and the adjusted constant adder is 5 following the conclusion of the minimum up. Under the minimum average cost approach, again, it's a similar calculation. We just need to replace the 2,500 with the 2,000. I didn't decide to drag you through all the math, but it is the case that the average cost is still minimized at 75 megawatts. Your average cost of operating at 50 would be reduced. It was $50 previously, now it's 40, but even at an average cost of 40, that means that increasing output from 51 to 75 at an incremental cost of $30 per megawatt hour will reduce your average. And so your overall average when you're operating at 75 megawatts is $2,000 to operate at your minimum, $30 times 70 times 25, which is $750 in total to operate from 51 to 75 megawatts. A total of $2,750 divided by 75 megawatt hours gets you to $36.67 per megawatt hour. So the next table, if we could go to it. So what this is just doing is it's essentially summarizing what I just went through. It's showing you the P-min block, the 2 incremental blocks, the actual offers that were submitted for each, and then the FRSP offers that would get either during the first hour, using each of the 3 different methods for advertising costs that we've described in previous presentations, and the FSP hours after that first hour, after the completion of the minimum uptime. And so you'll see when you compare the adders, suppose you went ahead and want to compare the constant adder columns, you'll see that during the first hour, they are $5 more expensive than they are following the first hour. That's because we took $500 in startup costs, allocated it over 100 megawatt hours during the first hour. 500 divided by 100 is $5 per megawatt hour. So that's why they are $5 per megawatt hour more expensive. If you compare the FSP offers during the first hour that were calculated using the adjusted constant adder to the ones that are in effect after the first hour, again, there's a $5 difference. We go from 40, 40, and 80 to 35, 35, and $75. That again is at the same explanation. $500 in startup costs for 100 megawatt hours is $5 per megawatt hour. There's a different difference for the minimum average cost approach. We go from 43.33 in the first hour for the first 75 megawatts to 36.67 following the first hour for the first 75 megawatts. That results because we have $500 in startup costs divided by not 100, but 75 megawatt hours. We're just allocating those costs over the first 75 megawatt hours under the minimum average cost approach. And 500 divided by 75 is $6.67. So that's why you see a $6.67 difference between the FSP offers during the first hour under the minimum average cost approach and the FSP offers following the first hour under the minimum average cost approach. Okay. If there's no questions, I'll go on to the second set of examples. All right, next slide, please. Okay, so as James was alluding to, this generator's minimum uptime was an hour, but that doesn't necessarily mean that it was committed to meet load throughout the next hour. And so the New York ISO and Potomac Economics, that's Independent Market Monitor, did an analysis in New York to basically try to assess when a unit is started, how long is it really started to meet load? And what they found was that most of the time, and I just quoted from the FERC filing here, that, the majority of fast start GT commitments are to satisfy immediate energy needs, so within 15 minutes of the resource's scheduled start. So for that reason, they go ahead and they allocate the startup cost to that 15-minute period. Is that always going to be perfect? No, it's not. There'll be circumstances when the generator was committed to be load for the next 30 minutes, or maybe for the next hour, or maybe for the next 5 minutes. But so this is not a precise mechanism, and you can imagine that the New York ISO could be doing an analysis at each point in time to figure out, gee, when I commit this GT, am I committing it to meet load? Over what period of time I truly commit it to meet load? That might be theoretically interesting and justifiable, but might be a little bit impractical. And so for that reason, they basically said, look, most of the time it looks to be about 15 minutes, and this will give us approximately the correct incentives. So we're going to go ahead and allocate the cost over the next 15 minutes. And the idea behind doing that is that gives people the incentives to essentially either get their generators onto the system when they're truly needed, or to take load off the system when it's really expensive to serve that load. So the idea is to try to go ahead and create better incentives, so that we're not essentially paying a generator for showing up 45 minutes later, when in fact the real need to go ahead and the real need for a generator was for it to be present earlier. So the idea here is to try to go ahead and allocate these costs in a way that tries to increase the likelihood that we are allocating them to the time when that's really appropriate. That's really the reason why we committed these generators. So if we do that, how does that affect the example? I'm going to run through some more numbers here. Next slide, please. So first, let's talk about how much of the commitment costs were allocated to the first 15 minutes. Under the New York ISO's approach, I said, of course, it's going to be the $500 startup cost allocated to the first 15 minutes, plus 1/4 of, I should have said minimum load cost, but I used the New York term, minimum generation cost, plus the minimum load cost for 15 minutes. So that's going to be $2,000 per hour. So for 15 minutes, that's going to be $500. So the total commitment cost that's allocated to the first 15 minutes is the $500 startup and $500 to operate at T-min for 15 minutes. So a total of $1,000. $1,000 goes to the first 15 minutes, and the remaining $1,500 in commitment costs, those go to the last 45 minutes. So we're allocating them disproportionately. We're on a per minute basis, we're allocating twice as much commitment cost to the first 15 minutes as we are to the last 45 minutes. So what does this produce? The first 15 minutes, again, we have two different adder approaches, a constant adder and an adjusted constant adder. What we do is we take the previous calculations and we do adjust the fact to account for the fact that one, we have a different numerator. We only have the $1,000 in commitment costs that are being allocated to the first 15 minutes. And the denominator needs to reflect the amount of output we're going to get when operating at Pmax for 1/4 of an hour. So $1,000 in commitment costs being allocated to the first 15 minutes divided by 25 megawatt hours, which is 100 megawatt Pmax times 1/4 of an hour. They give you 25 megawatt hours. So that gives you an adder of $40 per megawatt hour. So that's what you would get under the constant adder approach if you were to adopt a New York style mechanism of allocating all the startup costs for the first 15 minutes. If you were to do this and the adjusted constant adder approach, again, we'd have $1,000 in commitment costs that are being allocated to the first 15 minutes. We then subtract off what the imputed offer is to operate at Pmin, which is 50 megawatts, 1/4 of an hour. So that's $30 per megawatt hour times 50 megawatts times 1/4 of an hour. You multiply all those together and you get 375. $1,000 minus $375 is $625. 625 divided by 25 megawatt hour output. You get when you operate at Pmax of 100 megawatts for 1/4 of an hour. 625 over 25, and that equals 25. As it just happens, 25 squared is 625. So you have a $25 per megawatt adder using the adjusted constant. So that's what you have for the first 15 minutes using the two different adder approaches. What do you have for the last 45 minutes? Well, we do basically the same calculation as I just went through, just that we replace the $1,000 with $1,500 because that's the share of commitment costs that we're allocating to the last 45 minutes. And in the denominator, we need to replace the 1/4 hour with the 3/4 hour because we are allocating these costs over a 45-minute period, not a 15-minute period. So when we run through the calculations, you can see the details there. We get a $20 per megawatt hour adder using the constant adder approach and a $5 per megawatt adder using the adjusted constant adder approach. And if those numbers seem familiar to you, they should. Those are exactly the same adders that we have calculated a couple of slides ago when we were allocating the startup costs over the entire 1 hour minimum uptime for the period following the 1 hour. So that makes sense. Previously, when we were allocating startup costs to the first hour, then we got a certain set of adders for the second and subsequent hours that didn't include any allocation of those costs. Here, if we allocate all the startup costs of the first 15 minutes, then after those first 15 minutes are concluded, again, we have nothing left to allocate. And so we get the same offers after the first 15 minutes as we did in the previous example after the first hour. In each case, once we've concluded the period that we are allocating this commitment costs over, whether it's 1 hour or whether it's 15 minutes, we get the same offers. Next slide. Okay. I gave minimum average cost as on slide here. Again, we would have $1,000 in commitment costs that's being allocated in the first 15 minutes. So what would our average cost be during the first 15 minutes? Well, if we're operating at Pmin for 15 minutes, we have $1,000 in the commitment costs. We're going to divide that by 50 megawatt hours times, should be 50 megawatts, times 1/4 of an hour. That's going to get you to $80 per megawatt hour. So if you operate at Pmin for 15 minutes, you have to recover, your average cost of operating is going to be $80 per megawatt hour. So that's recovering your $1,000 commitment costs covered, allocated over operating at Pmin for 15 minutes. If you then were to increase your output for the 15 minutes from 50 to 75 megawatts, we have some additional costs to include in the numerator. We would include the cost of operating at $30 per megawatt hour times 25 megawatts for a 1/4 hour. But now we're going to be advertising that over 75 megawatts times a quarter of an hour. And that's going to get you to a 63.33 average cost. And then we don't, again, need to go any further. We know that the third step of the bid for that last block is going from 75 to 100 megawatts. It's a $70 offer. If you have an average cost of 63.33, adding $70 energy is only going to increase your average cost. And so for the first 15 minutes, you get an FSP offer of 63.33 to go up to 75 megawatts. Anywhere between 0 and 75 megawatts will be offered at 63.33. And beyond that, you would use the $70 per megawatt offer that was actually submitted for the unit. So again, that's what you would get during the first 15 minutes. What would happen after the first 15 minutes? It will be the same as what we talked about before. The offers that apply following the first 15 minutes under the New York approach would be the same as the hours that apply after the conclusion of the full 1 hour minimum of time under the approach that allocates the startup costs evenly over the entire hour. And so you can go ahead and see that if we go to the next slide. So what the next slide does is the first table there is the table that I showed you before. It's the offer. It's essentially what the fast start pricing offers would be under the 3 different approaches for calculating adders. And so you can see there's one set that applies to the first hour. And then the second set of offers is after the conclusion of the 1 hour minimum. Bottom table is not, it's similar, but it's not the same table. It just summarizes what I just presented. And so what you see there is one set of offers that is the fast start pricing offers that would be used during the first 15 minutes, not the first hour. And then the second set of bids, second set of offers is what would it be in effect after the first 15 minutes. And so if you go ahead and you compare the FSP offers that are made after the first hour, if we allocate the costs equally over the 1 hour minimum uptime, so that's the right hand part of the first table. And on the other hand, the FSP offers that would be in effect after the first 15 minutes, when we allocate the startup costs over the first 15 minutes, so that's the right hand part of the second table, you'll see those are the same. The offers in the right hand part, first and the second table are both the same. But if you go ahead and you compare kind of the middle portions of those two tables, you compare the FSP offers during the first hour in the first table, the FSP offers during the first 15 minutes in the second table, you can see that the second table tends to have higher offers. That makes sense. It's a situation where allocating all the startup costs to 15 minutes as opposed to allocating them over a 1 hour period. And so we tend to get higher offers for the first 15 minutes if we allocate the startup cost to the first 15 minutes. And then, lower offers for minutes 16 through 60 because we've already taken care of allocating all the startup. Whereas under the approach for the top table, we still have, startup cost to allocate as we go through the entire, as we go through the rest of the first hour. If there's any questions, I'll pause for a second here. And if there's not, I have one more slide before I pitch it back to Jane. Okay, one more slide then, please.
Hand did pop up, sorry.
So we do have a question or hand raised from Stuart. Stuart, your line is unmuted.
Michael, thanks for this. And this may be difficult to do, but I'm just trying to think in my own mind. On a resource level, let's say this resource is setting the fast start pricing under these different options, be it during the hour or during 15 minutes. I'm trying to compare what that resource would get paid under the current construct, non-fast start pricing in CAISO, to what that resource would get paid under these different options. Is there some way of trying to do that apples for apples comparison in some of these scenarios? It's maybe a difficult question, but is there some way to do that? Because I'm trying to understand how much better off a particular resource would be under this fast start pricing construct versus what it ultimately gets paid today. And then obviously these prices apply to total market if it's setting the price, which is probably where I have the heartburn. But is there some way of doing that?
Yeah. I mean, it does get difficult because first of course, we're actually talking about three different proposals: constant adder, adjusted constant adder, minimum average cost. They all have different answers. And even if we go ahead and keep it within one of those particular approaches, you know, for a minimum average cost, for example, it goes ahead and allocates the cost initially to the lower blocks of the unit. So in this example, in these examples, these are situations where none of the commitment costs get allocated to that second incremental block. It just always, you know, the application of fast start pricing doesn't affect its bid at all for that $70 block. It does affect the offer for the lower blocks. In other circumstances, I can make other assumptions where it actually will, you know, increase the offer for that last block. You know, there are some units that their minimum, the output level that minimizes their average cost is Pmax. And so for a unit like that, under fast start price, under the minimum average cost approach to fast start pricing, it would just have a single bid that would apply to, you know, its entire capacity. So the difference between those two, of course, is that under the current approach, if we dispatch the unit into that second incremental block and we're using minimum average cost pricing, we have a $70 price either way. We haven't changed the bid any when we do the pricing dispatch as opposed to the actual dispatch. Whereas in the second example, where I go ahead and I assume that the cost for the unit is minimized when it's at Pmax, then we are using a different bid for that unit in the pricing dispatch than in the actual dispatch, and so that would increase its price. So it's going to be case specific, even for a given mechanism like minimum average cost. For adjusted constant adder, that's going to be yeah, again, as was the case with Alva's.
The reason I asked the question is fast start pricing is going to increase prices to customers. And I think in this initiative, if I recall, the reason we're looking at that is to improve price formation itself. And I would imagine to try and attract higher or better quality resources. But I'm trying to understand, is it really going to do that? How much better off is that higher quality resource going to be under one of these examples here compared to the status quo? Because all generators are getting this price. So you know, the customers are going to pay for this. We're not chasing reliability here with this. We're chasing, you know, we're chasing improved price formation. And,
Yes.
and I haven't seen a lot of discussion around why this improves price formation versus the different approach the different markets are taking or we could take as options. You know, I understand the different options here, but I don't understand why one is better than the other and why it improves price formation over what we're currently doing today. So that's why I'm trying to compare to today. What does this look like? And can I believe that we're going to attract higher quality resource because of this, or just end up paying for inflexible resource?
Yeah, I mean, I guess I would say, and James, you know, please feel free to jump in here. I mean, I think that was what we were trying to emphasize in some of the earlier presentations, as opposed to this one, which is admittedly more focused upon the mechanics and trying to go ahead and ensure that we, you know, trying to talk about how to allocate these costs when you're coming up with the price that would be used in the pricing dispatch under fast start pricing in order to ensure that they, you know, costs are being allocated to the time period that is most appropriate. I mean, I think more generally, if we talk, you know, about what the concepts are behind this, the idea is to go ahead and ensure that we have prices that are as reflective as possible of the actual costs that are incurred on the margin to meet load at a given time. And to the extent that we continue, that we use the current mechanism, which, may dispatch relatively expensive resources and not set prices that are commensurate with their expense levels because they, happen to be block loaded resources, for example, that technically cannot be marginal. They cannot actually increase their output by a megawatt in order to satisfy an additional megawatt of load. That those price signals are not truly reflective of what the actual cost is of meeting load at that particular point in time, and that can give poor incentives for example, bringing in imports or giving loads an incentive to get off the system.
And fair enough, if we feel we're past that point in the discussion, I'm okay. I just, in the analysis, if we could look at total revenue in some way, if it was possible, to look at the total revenue that resource that's setting the price gets under the fast start construct versus the day, that would be helpful. I know it's a difficult question, but
yeah, well, I mean, I guess my question would really be, I mean, I know that Guillermo went ahead and did a fair amount of analysis on that, and so I guess speaking for Cal ISO, which I shouldn't be doing, it might be good to know.
Well, we can maybe we can maybe leave it there, Michael. It's just a concern. I don't want. I'll let you continue, but just maybe if you guys can think about if that's possible, but we don't need to go, prolong this. It's okay.
Dan, do you want to
Stuart, this is Danny with the ISO, and you're asking a fair question, right? There's a lot of different ways to do price formation. FERC has indicated fast start pricing is a reasonable approach because, as Mike indicated, you want to reflect the marginal cost of serving the next increment of demand in the interval you're trying to clear. The broader question about what are the reliability or market impacts of that is something that we want to explore with this exact group. The ISO doesn't have all the answers on this. A lot of stakeholders have advocated for fast start pricing and exploring it, and that's something that we will need everybody's help with, understanding what the potential benefits of moving to this type of pricing design would be. So the ask would be from the CAISO to work with us and help us understand how this will improve market outcomes for everybody, or not improve market outcomes for everybody, but getting more voices and opinions in the room on this specific topic would be appreciated. So thank you for flagging this, though, Stuart, as a valid topic of discussion.
Yeah, because generally, Danny, I mean, if you've got a better quality resource, like a fast start resource or whatever, that can respond quickly, fair enough. I get the rationale that you potentially could command a higher premium, but we're looking at two distinct things here. Are we trying to do this for reliability, or are we trying to do it for price formation purposes? The second, or the latter, the price formation, is a little bit more difficult for me. If it was pure reliability, it's not fast start pricing I'd be looking at. It's some kind of capacity product, or even fast start as a service, as some other global markets have done. Some other markets have done. If we're purely chasing reliability, but I thought in earlier discussions we excluded this as a reliability need. This was more simply for price formation purposes. But are you saying we're really looking at this from both aspects now, not just price formation?
We're looking at this from a price formation aspect. If this has reliability benefits, we would like to hear those. I know ISO New England, for example, one of the reasons that they pursued fast start pricing is because they had a large number of resources who this made them essentially more inframarginal more of the time. Their concern was more, do you have a large subset of your resource fleet that doesn't see a lot of value in combined revenues coming out of the capacity and energy markets to stay online and be able to reliably operate the grid? Now, that probably isn't the case for the control area that the CAISO will be operating, but again, we would like to know that from market participants who are operating these resources. But
yeah, exactly.
More generally, this is a price formation. At least to date, this has been largely like, what is the correct price formation to essentially account for meeting that next increment of demand?
Exactly. So it depends what problem you're solving, because if it truly was a reliability, or like in the New England case, then the question becomes, do I want to pay higher prices to compensate those slower resources, or do I want to try and look at some way from a reliability perspective of attracting high quality resources, be it through some capacity product, and reward them to be available to solve my reliability needs? So it's really what problem are we trying to solve? I thought we narrowed it to simply price formation, and that's why I start to have heartburn and start to think about, well, how much better is that? How much better off is that particular resource that sets the price under this fast start construct than it is today? But yeah, good discussion. But that's just where my thinking is.
Thanks, Stuart.
Okay, were there any other questions? Okay, next slide then. I've got one more, I believe. Sure. So what we've been doing here, what I've been doing here is, really allocating startup costs differently over the hour versus the 15 minutes. And in particular, illustrating the New York approach, which allocates, them over a shorter period. There's no particular reason why that should be limited to the startup costs. The other component of commitment cost, of course, is the minimum load costs. And there's no particular reason why you couldn't allocate them unevenly. So for example, in this, let's suppose that this fast start generator, it was committed as a 1 hour minimum uptime, but it's really being committed to be low to the next 15 minutes. And we take a look at, the forecasted value of energy at the time that we commit that resource, and we say that, gee, it's looks like that the last 45 minutes that it needs to complete its minimum uptime, the average LMP is going to be $25 a megawatt hour. Well, in that case, we're saying, gee, what is the value? What is the expected value of that energy that is going to produce to complete that minimum uptime? Well, it's $25 times 50 megawatts at Pmin times 3/4 of an hour. So the expected value of that energy is $937.50, and I'm wishing I'd $24 instead, which would have given me rounder numbers. But anyway, so it's $937.50. And so, gee, if I incurred $2,500 in order to start this unit, and the value of the energy it's going to produce over the last 45 minutes that is necessary to complete its minimum uptime after that 15-minute period for which it's really being committed is $937.50, then there's an argument that says that, well, in that case, what you really should be allocating to the first 15 minutes is $1,562.50, not just $1,000 of commitment costs. And so you shouldn't just allocate the startup cost of the first 15 minutes. You should also allocate a chunk that would be a little bit more than, a significant chunk of the cost associated with running at minimum load for the last 45 minutes and allocate that to the first 15 minutes. I think that's a very valid argument. But what would happen if you did that? Well, the first thing you'd get is you would get potentially a little bit odd looking results. You recall in that table from the previous slide that we basically showed that if we allocate startup cost to the first hour, then we have a higher set of FSP bids for the first hour and then a lower set of FSP bids following the first hour. We allocate the cost of the first 15 minutes, then we have a higher set of bids for the first 15 minutes and then a lower set for after the first 15 minutes. If we were to go ahead and do it this way, then we'd have a situation where we have an even higher set of bids for the first 15 minutes, then a lower set of bids for the next 45 minutes, and then something in between following the completion of the 1 hour minimum uptime. So once we went from minute to 60 to minute 61, the cost would actually go up because we would not be allocating for minutes 16 through 60. We're taking a portion of the costs associated with operating at your Pmin for minutes 16 through 60 and allocating it to the first 15 minutes. Once we get to minute 61, we wouldn't be allocating costs away from minute 61 any longer. And so the offers would actually be higher for minute 61 than they are for minutes 16 through 60. Now, I actually think that makes sense once you stop and think about it, although it takes a little bit of time to get your brain around it, because, you know, once we get to minute 61, we don't need to go ahead and continue operating the unit anymore. We can shut it off whenever we want. So it may not make sense to go ahead and allocate any cost away from that period of time. Whereas when we're at minute 59, we don't have that option. We have to keep it going until minute 60. So once we cross the barrier going from minute 60 to minute 61, actually we start incurring some costs again. And so it actually may make sense for the offer to go start up high, then go low, and then come back up once we complete the minimum uptime. It is a little bit weird though. And then the other thing that is probably the killer is that, you know, just as I was talking about the New York ISO's approach where they allocate to the first 15 minutes, which is not always going to be the right answer, but it's intended to be rough justice and be something that is close to the right answer most of the time. We have the same downside here. If you were to do this, you'd have to go ahead and be all the time saying, gee, we started this unit and for how long is it needed? And what is the expected price after the period at which we no longer need it? And that is the approach we're going to use to come up with the with this adjustment that was $1,562.50 in this example. It's going to be, it could be different than 15 minutes all the time. It could certainly that $25 expected LMP that I just grabbed out of the air is going to be something different all the time. It's a significant increase in complexity and resources needed for computation. So theoretically, it's something you can do, and something that really actually makes sense, I think. Practically, it might be a little bit too cute. So I did just at least want to go ahead and cover off that possibility and discuss it, because I think it's, you know, something that's legitimate to consider, but might not be practical from an implementation perspective. With that, if there are no questions, I will pitch it back to James to the last several slides.
All right, thanks for that, Mike, and good discussion in that section. So we're going to transition now to the second block of this presentation today, which talks about fast start pricing in the day-ahead market. So just a few slides here to tee this question up here. First, again, like we did with the previous, there is some guidance from FERC through their NOPR in 2016 on whether fast start pricing should be in the day-ahead market or not. And FERC argued that it should be, and that there were two reasons that it gave for doing so. First, to the extent that fast start pricing improves price signal accuracy, doing it in the day-ahead market is just as good as doing it in the real-time market to properly reflect the marginal cost of fast start resources that may be needed. So there's no inherent reason why they shouldn't be present in both markets. Second, the FERC argued that it better supports price convergence between the markets. When you have systematic modeling differences and pricing differences between your markets, it creates inefficient arbitrage opportunities that virtual suppliers or others can take advantage of. And so generally speaking, they felt like in support of better price convergence, that it made sense to think about fast start pricing in both the day-ahead and real-time markets. But as we'll see, it's not, that relationship is not always perfect, and we have a couple of case studies to share. Let's go to the next slide, please. Very simple table, we won't dwell on it, but of most markets other than ISO New England have fast start pricing in their day-ahead market. So on this next slide, if we can go to the next slide, we'll look at basically what ISO New England said in response to FERC when it was compelled to do fast start pricing. And ISO New England basically presented some practical concerns about implementing fast start pricing in the day-ahead market. And this was several years ago, so I will caveat that this may not be the ISO New England's current feelings about fast start pricing in its day-ahead market. This is several years old, but this was information that we got from their public FERC filing in response to fast start pricing. ISO New England argued that the benefits would be minimal because most fast start resources are committed in real time, not day ahead. So you would expect the impact of fast start pricing to be smaller in the day ahead market. And there was a practical concern really where they viewed the required software changes and implementation costs that they would need to have undertaken as exceeding the limited benefit that they saw of implementing fast start pricing in their day ahead market. Second, they identified at that time, some unresolved market design challenges, which may no longer be unresolved, but at least at the time, ISO New England argued they were, which is first, whether to include lost opportunity cost payments in the day ahead market. So ISO New England and PJM, who we'll hear from in January, do have a settlement mechanism to compensate generators who are dispatched below their price optimal point. They pay them these lost opportunity cost payments to incentivize them not to deviate from their dispatch and essentially chase the higher price. And ISO New England questioned whether lost opportunity cost payments are appropriate in the day ahead market, since most of the time the resources are not actually committed until the real time. So lost opportunity cost is a different form of uplift payments that ISO New England and PJM pay to their generators. Second is that how to handle resources with sub-hourly minimum run times when the day ahead market solves on an hourly basis. So for example, if you have a resource with a 30-minute minimum run time, but you're solving for an hour, an hour by hour basis, the bids are submitted by hour, and also the granularity of the market interval is 1 hour. What's the proper way to allocate a sub-hourly commitment cost into an hourly portion? And to double down on that, also that you may have a resource that has sub-hourly commitments that span across 2 intervals. So you might have, even if the resource has an hourly minimum run time, it may be started in one interval, if the resource has something like a 45-minute minimum run time, it may, its commitment may span intervals, and it may be challenging to decide what to do with those sub-hourly costs. So those things may have been resolved, but that is at least what ISO New England argued to FERC, and FERC agreed. So that highlights why ISO New England was hesitant to extend fast start pricing into its day ahead market. It'd be interesting to see if they have experienced any impact with virtuals in the day ahead market, because what we're going to argue in a few slides is essentially that, look, whether or not you implement fast start pricing in the real day ahead market or not, because virtuals are able to participate in the day ahead market, you may get, and they're incentivized to participate in a way that converges the markets, you may get fast start, the price effects of fast start pricing in your day ahead market anyway, except instead of paying, that to the fast start resources, you're paying it to the virtuals potentially. So interesting step there. Let's go to the next slide, please. Okay, so 2 key points here on implementing fast start pricing in day ahead markets. As ISO New England argued, and we'll see on the next slide, the practical impact may be minimal. Day ahead markets typically have much more flexibility and options to meet load, which reduces the likelihood of needing to commit fast start units. And so the benefit of that comes from the full 24-hour look ahead that the day ahead market is using, but also the hourly granularity of the market tends to make it easier for the market to avoid the need to commit an expensive fast start resource if it has other units available for the flexibility. Second, as I just mentioned, even without explicit fast start pricing in the day ahead market, virtual bidding may bridge the gap here, and market participants that anticipate fast start pricing impacts in real time may adjust their day ahead positions accordingly, which would converge the prices naturally between the 2 markets. But as I just argued, whether or not you have it in the day-ahead market, this fact may generate the effect of having fast start pricing in the day-ahead market anyway through this type of participation. Next slide, please. So here's some evidence from market monitors and what they've observed about fast start pricing impacts in different markets in their day-ahead market. First, PJM's independent market monitor found a notable difference between real-time and day-ahead impacts in 2023. In real-time, the fast start pricing increased prices by about 6.8%, or roughly $1.97 per megawatt hour on average. But in the day-ahead market, the impact was minimal, just 0.1% or 4 cents per megawatt hour. So just to emphasize, in the PJM market, the impact of day-ahead, of fast start pricing in the day-ahead market is minimal. The MISO market monitor reported that the extended LMP or ELMP version of fast start pricing that they use, quote, had almost no effect in their day-ahead market. And they attribute this to the greater supply flexibility and the presence of virtuals in the day-ahead market. So we will be able to, if folks are interested, we'll be able to ask both sets of market monitors about those types of impacts in future sessions. Interestingly, SPP's experience differs. So I couldn't find in the most recent SPP Market Monitor annual report the price impact of fast start pricing in their day-ahead market, but we'll note that their market monitoring unit reports that a large percentage of fast start resource are clearing in the day-ahead market. So that is sort of counter to the logic that we had just said, and essentially showing that different market design and resource mix can lead to different outcomes across regions. So I imply through the market monitor's comments that the price impact of the fast start pricing in the day-ahead market for SPP is rather small, but that is, again, just sort of trying to read through the lines. There's no, as far as I could find, any price impact that they note. So these findings generally support the theory that day-ahead impacts tend to be muted, though SPP's experience seems to show that this isn't universal. Yeah, so that's some evidence here from other markets about fast start pricing in day-ahead markets. Can we move to the next slide, please, just to confirm that may have been my last slide? Okay. So we'll pause here. That concludes my remarks on fast start pricing in the day-ahead market. I'll pause here to see if my colleagues want to add anything or Mike wants to add anything, and then I'll also pause to see if there's any questions or comments on this material from this stakeholder group.
Yeah, there was one thing I forgot to mention during my slides, which was one error that when I was talking about New York allocating the startup costs in the first 15 minutes, that's only in the real-time market. They can't do it in the day-ahead market because, of course, they don't have 15-minute granularity, so they just allocate it over the entire hour. But I didn't mention that, so I just did want to correct that.
Thanks, Mike. I see one hand raised in the queue.
All right. Yep, see one hand raised. Caller, your line is unmuted.
Hi, this is Callie Wells with WPTF. Can you guys hear me okay?
Yep.
Yep.
Okay, couple of questions. Well, quick one reaction that on allocating it over the 15-minute granularity. I was wondering how the CAISO would handle that, given that our bids in real time are hourly. Would we even be able to do that, or would we have to allocate it over a 15-minute interval, but then allow that to be the full bid use for the hour?
That's a good question. I will provide my response, and if somebody from CAISO's technology team wants to raise their hand and overrule me, please do. But yes, the bids are submitted hourly, but for every market run, let's just think about RTD, for example. you would have 12 RTD intervals that are using the same bids, because you know, 5 minutes times 12. So the same bids are used for 12 different RTD intervals, but you could apply the fast start adder in any of those 5-minute intervals, or stop applying it in any of those 5-minute intervals. It's just that you are using the same submitted bid to essentially construct the modified offer curve that may or may not apply, you know, within any of those 5-minute RTD intervals. Does that make sense?
I think so, yeah. So you would end up with a different bid potentially used in each 15 or 5-minute interval, depending on how you adjust it or not.
Yeah, so it would be constructed using the same submitted bid, but you may or may not apply the fast start pricing adjusted bid in that market run, depending on the direction we go here.
Gotcha. Okay, that makes sense. And then I guess one reaction to whether or not it should be in the day ahead, just maybe another thing to consider is if you don't have the same price formation between the two markets, I do wonder if that creates an incentive for the resources to bid in a way to not be dispatched in the day ahead market so that they could capture higher prices in real time.
It's a good point, because you're right that if there is no fast start pricing applicable in the day ahead market and a fast start resource is committed in the day ahead market and then settled based on those prices, they will not recover those costs through the LMP. And so they essentially forego the recovery of, at least they forego the recovery of those costs through the LMP. They'll still have bid cost recovery to make them whole to zero, but you're right. So that definitely is a good consideration. And maybe because of that fact, they may, you're right, have some sort of bidding response in a way that keeps them from being committed in the day ahead market. That's a good point.
Yeah, it's just something, I mean, those were all great points to consider, just something else I wanted to throw out there.
Yeah, I think that's a fair point, but also, as James mentioned during the presentation, you know, I would expect the vast majority of the impact, or the expected impact of the day-ahead market, will already be reflected through the you know, through the actions of virtual bidders. So that impact would probably be limited to situations where a fast start generator was committed in the day-ahead market. Yeah, even if it's committed in the day-ahead market, then it's expected to be committed, so you'd expect the prices reflected back from the real-time market should cover its commitment costs. So I suspect that the impact would be
pretty. James, I wanted
Did I lose my audio? Was that?
No, you're still there, Callie.
Okay, the audio dropped. I wasn't sure if that was me or the speaker line.
You need to have Mike repeat his comment. Did you miss the comment?
No, I think it's just he dropped off at the tail end, but I just wanted to throw that out there as something else to think through. And then I had one last quick question, and then I'll be done. Sorry, I waited to the end to ask all my questions. One, as we're thinking through like the 3 different possible options here, and I believe you guys might have presented this data earlier, and it's just escaping my memory. Do we have a good idea as to the resources that would qualify for fast start pricing? Are they generally committed and sitting at PMIN, or are they generally committed and sitting at PMAX? Or is it kind of distributed evenly? Because I think it would be good to have a grasp on that, because obviously the different options will result in different LMPs and impact to the LMPs if they're all sitting at PMIN versus if they're all sitting at PMAX. Because I think like one of them would adjust the price curve entirely, but one of the options looks like it only would adjust the price curve and impact the LMPs if they're sitting at PMIN. But if they're predominantly all dispatched and sitting at PMAX, and you go with, I think it was that third option, we really wouldn't see any pricing impact compared to what we have today. So I don't know if you have that on hand, that data on hand, but if you don't, I think that would be useful to have an idea of.
Thanks, Callie. as far as I'm aware, the CAISO analysis from April does not have that information, but I think it is a worthwhile extension to maybe take a subset of FASTAR resources and to see, you know, some sort of distribution about where they're typically operated. And it may be spread out, it may be, you know, really clustered around PMIN or really clustered around PMAX, but yeah, that may be good evidence to support one sort of amortization approach over another. Because I guess to extend your point, you could say that, well, if your FASTAR resources are typically operating around PMIN, then you may favor methods that amortize or recover more of the cost in the earlier bid segments. And if they're, you know, clustered around the PMAX, then maybe you have a different sort of approach. So, so yeah, that we can take that back and look into that and hopefully come up with something like that for a future session.
Okay, yeah, great. Because I'd hate for us to go through all this effort, decide on an option, and then when it's implemented, realize, oh, that doesn't really have the impact we were thinking because, you know, it's all the resources, for example, are dispatched up to the PMAX, and we chose an option that didn't change the bid curve at the PMAX. So, all right, thank you. That's all I had.
Thank you.
All right, so it looks
James,
like
on the topic of the fast start pricing in the day ahead, I wanted to add one additional item for thought by this body, and that's the potential impact on the imbalance reserve product. In the slide that you had kind of sequencing our discussion of fast start pricing, we plan to talk about the impact on the flexible ramp product, but a choice to implement this also in the day ahead market may have some of the same concerns about what is the point you're trying to calculate uncertainty from for your imbalance reserve product procurement. So just everybody be conscious that that is an additional consideration and potentially an item that we'll get to work through if we ultimately conclude that also implementing this in the day ahead is appropriate.
Thanks, Danny.
all right, it looks like we do have another hand raise from Ellen. Ellen, you are now unmuted.
Hi, thanks. Ellen Wolf for Zero Consulting. And this question's been in the back of my mind, and with Callie's question, it kind of reminded me. It seemed to me like the resource that's setting the LMPs is not necessarily the one you have to look at for incentives. It seems like the bigger impact would be to the inframarginal resources that wouldn't be getting as high a LMP, but for this fast start pricing. The one that's setting the prices is probably doing okay anyway, I would expect, and the bigger impact would be to the ones, you know, that don't have the highest bids clearing the market. Am I wrong about that?
So I can take a stab at that. So it does seem to me that the marginal resource under fast start pricing doesn't seem to be better off in this case because the marginal resource is recovering their costs through or at least getting their costs recovered through the LMP, and would have, if they were dispatched absent fast start pricing, would probably have been compensated the same amount. But you're right, the inframarginal units who are in the money and are making a profit in that interval, with fast start pricing would have larger profit, you know, would see larger compensation in that. So if you're not already being compensated through uplift, your revenue is increasing and generally you're in a better situation. Mike or Danny, do you see it any differently?
Yeah, the one caveat I'd say is with not the adjusted constant adder, but the ordinary constant adder approach, because it actually double counts some prices. You're being dispatched based upon one less expensive actual set of offers submitted, and then the pricing dispatch uses a set of offers that makes you appear more expensive than you truly are. So that actually might lead you to over recover your costs. So the marginal unit actually might be better off because of that. So that would just be limited to that one approach.
Okay.
And
Yeah.
James, that's a fair characterization.
Okay. Yeah, it just seems like when you're looking at incentives, it won't be quite so easy, because the incentives will affect a lot of units and not just the marginal unit. So I don't know. It's a tough question, I think. But thanks. Very good discussion.
Yeah, thanks for the question. Another thing I'll just throw into the rink here is that, as Mike alluded to earlier, if you're any sort of price responsive resource, that could be an import or load or storage or any sort, that you will have under the fast start pricing construct, you will that will potentially change your incentives in a way that you might be more willing to offer at certain times because your expectation of the fast start price to bind at certain times. And so you have, for some resources that are trying to operate all the time, their relative incentives may not look much different. But for some resources who are trying to be more sort of price responsive, it could be have pretty large changes in their incentives to offer and times that they offer.
All right, it looks like we have another hand raised from Stuart. Stuart, you're unmuted.
Thank you. Just to build on Ellen's point, I mean, I accept there might be some minor differences for the marginal unit. And it's that inframarginal units. It's not only that, but there's a bunch of generation, let's face it, that is going to get paid this fast start price that absolutely don't need it. And if you're not solving a reliability problem, then that would make you pause, given the complexity and all the issues that come with this. And I agree with Carly's point, you need it in day ahead. You can't just have it in real time. Given all the issues that come with it, do you really need to compensate all those resources that don't need this unless you have a reliability problem? That is the issue that I have with the approach.
Yeah, the only thing I'd add, well, just two pieces of context I would add. You're right, it's paid to the market. In real time, it will be paid to any incremental, only the generators who are providing incremental energy at that point. So for example, if the fast start price is muted in day ahead and 90% of your supply is settled there, then the fast start price will only be paid to those that are providing the incremental quantities. But also note that if you are getting a decremental schedule or you fail to perform in real time, the generators are also paying back the higher real time LMP too. So there are potential, it does work both ways in some sense. I think that the overall direction is, you're correct, the overall direction is in the positive way, but for some reason it can make generators less profitable if they're not available at the times that they're supposed to be, or they're getting decked at during the fast start when the fast start pricing kicks in.
I think generators are going to chase price unless, as Michael discussed, or you, James, discussed earlier, there's some kind of mechanism to stop price changing. The other thing that, as we talked about convergence bidding, any EDAM, and this may play into the timing of fast start pricing and when you want to consider it, but in EDAM, there won't necessarily be entities with convergence bidding, certainly at the outset or when they initially on board. And that really gives me, we need to look at that and understand that, because if you introduce this before convergence bidding, I'm not sure what the impact would be, but we just need to bear in mind, I don't think there's a tariff yet that has been drafted or proposed or is even at FERC that includes convergence bidding from the outset.
That's a very good point, Stuart. Thank you for flagging that, because to the extent that you assume convergence bidding will bridge some of the, or price discipline some of the bidding strategies. Not having it be ubiquitous within the market could lead to unexpected outcomes.
And I think the convergence bidding itself may, on the one hand, you hesitate to have it because there may be some issues as EDAM gets built out. And the other hand, you think, well, it's maybe inevitable that you need it, but it will take a little bit of time to settle down. So, and I think ISO had that experience.
There were a few questions submitted in the chat I want to make sure we address. The problem is I can't tell which questions were submitted to all panelists, so I don't, or all attendees, so I don't know to the extent with which others can see these questions, but
I can read it out loud if you like.
Sure, that'd be great.
I think that would be great.
All right, so first question was from JK. This is a follow-up on Kelly's question. Can Kaizo provide some insights how often FS resources are dispatched in the DAM?
Yeah, so I don't have a perfect answer to that, but typically many FastStart units are committed in the day-ahead market, or in the case of the energy imbalance market, may already be committed in base schedules. And so I don't want to throw a number around, but it's a minority of the time that a FastStart resource is economically committed in the real-time market. But we can add that to the list of things that we might want to provide an extension of some more analysis on to help this question.
All right, and then second question is from Drew Gray from Rev Renewables. Since the benefit of fast start pricing is reducing out-of-market payments, shouldn't we understand how expected BCR payments reduce under the different scenarios in current status quo to be able to measure the efficiency of each approach or efficacy of each approach? If so, will this analysis be made to better understand the impacts?
That's a good point, but I would call it a sort of a longer term question. I think we do need to understand that, but I think first what the working group should accomplish from my perspective is that we should sort of corral around a preferred method, I guess. And then once we have, based on those merits, that method, then we may be able to do some targeted analysis to see some simulation about how that might impact bid cost recovery. Just because it makes it really challenging when you do analysis with all these different scenarios, just exponentially increases the effort. And so from our perspective, what we were hoping to accomplish is to, collaborate on sort of a preferred approach to go forward and then apply some additional analysis to that method to see what the impact would be.
All right, it looks like that is all the questions that we had.
Okay, well, thanks everybody. I will turn it over to Brenda to close us out.
Thank you, James, and thank you, Danny, and thank you, Michael, and thank you, Ryan, for helping out for this call. So we just want to go quick on the last steps for this meeting. We did update the schedule as well. We are updating the initiative webpage under proposal development phase. That's located on one of the first columns. It'll showcase all the dates that we have planned, as well as the upcoming two meetings that we have in schedule for December 16th and December 19th. We also are monitoring any questions being submitted through ISO Stakeholder Affairs for any participants who want to speak at upcoming meetings. Like James has mentioned, we do have a few speakers from ISO who will be presenting that notice. One of the notices for the 16th has gone out today, and then the other notice will be going out next week for the 19th. We also have the upcoming deadline of the comments due for the First, session 1 and 3 for the BA Market Power Mitigation Working Group sessions. Those are due on 13th on Friday. We did give everyone plenty of time to submit comments, so hopefully everyone could get those comments in before the 13th for those that set of sessions that we have given for our participants. And then next is just a slide that I have created for those who are following us on different initiatives. Just an outline. We do have a pretty busy week next week. We do have the Storage Design and Modeling Working Groups kickoff call on December 11th. We have the Market Performance and Planning Forum on the 12th. This meeting, we do highlight a lot of the initiatives such as price formation, and Becky Robinson will cover a lot of the different initiatives going along from the 2024 to 2025, and also the policy roadmap and catalog items that we are adding for next year, which is also the Storage Design Modeling Working Group. We do have a winter readiness training for scheduling coordinators on the 12th at 1, and then followed by a tariff clarification for the draft tariff language for the aftermarket fuel cost recovery at 2 to 4. And then we do have that comments that I mentioned due for, well, we do have the comments I mentioned for the price formation on 13th, but also the comments due for the congestion revenue rights enhancement working group that also kicked off last month. So those are due on the 12th as well. And then lastly, we do have a resource adequacy modeling program design workshop that has been changed to virtual format. That notice went out today for that 13th call on December 13th. As well, we do have those 2 working groups that we mentioned for price formation, 16 and 19. So it is getting a little busy, so we're spreading it out evenly throughout the day so our folks, stakeholders can attend all these calls at the great times that we have provided. And then we also have one more slide just to showcase the Energy Matters. The newest one we just posted yesterday was the 2024 Year in Review by Elliot Mazer. So that shares a little bit of what we accomplished this year and objectives on grid reliability. And then also just a reminder, we have posted those YouTube videos for the Stakeholder Symposium on our California ISO YouTube channel. At this time, thank you so much for everyone for joining. We appreciate everyone's participation and questions. We look forward to seeing you at our upcoming meetings, as well as the next meeting we have for price formation on the 16th. And then we'll be adding those meetings with more notice for the ones in January, February, and March. So those ones will definitely be added so we can give stakeholders enough time to put those on their calendars. And if there is something that you see that might be conflicting with something major within the outside of ISO, please let us know and email us. We definitely like to make sure we are targeting the correct audience during a stakeholder call so we can accommodate those meetings for everyone. And that's all I have. So I'll pass it back to Ryan, our event producer, to close our call. Thank you.
All right, that concludes our conference. Thank you for using Inteller Event Services. You may now disconnect.